we're back, everybody. In this video, we're going to see how to apply that formula for sum of terms in an AP in real life. How do we apply it? So this question goes this way. The starting salary for a particular job is 1.2 million naira per annum. The salary increases each year by 75,000 naira to a maximum of 1.5 million naira. First step. A. In which year is the salary or is the maximum salary reached? B. How much money would a person make or earn in that time? Solution quickly. So the thing is, the starting salary for a particular job is 1.2. I set this as my A, the first term. So A is equal to 1.2 million, right? So 1.2 million naira. So, but this can actually be, let me change it to numbers. 1,200,000. That is it. 1,200,000. Okay. Next we have the salary increases each year by 75,000 naira, meaning D. This is the common difference. You don't have to think so much about this. So it's 75,000 naira. See that? This is 75,000 naira. That's the D. Every year it changes by 75,000, and so on. So that's our D. Now, to a maximum of 1.5. So that's the last term. L is equal to what? 1.5 million naira. So this can actually be written as 1,500,000. You can do that, okay? And you can actually work with this ones in million too, no problem. But you keep in your mind that you're dealing with it in millions. So that's it. Now, the question is, in which year is the maximum salary reached? You don't know which year. So that suggests that N is question mark. You have to find N. N is question mark. So N is question mark. So therefore, I have to find N. We set up this formula. Remember, we have the nth term. This is an AP. Of an AP is A plus N minus 1 D. This is the nth term of an AP. And so that means I can set this one always with L. I've told you that. So that means we're going to have 1,500,000 is equal to the first term is 1.2, which is 1,200,000. 1,200,000. Okay, like this, plus N minus 1 times D. My D is 75,000. Like this. So the Tn is the last term actually. Okay, so we have to solve for N. Like this. 1,500,000 is equal to 1,200,000 like this, plus 75, if you open the bracket, 1,000 N minus 75,000 like this, if you open the bracket. So that means that I can collect like terms. This I'll leave it here. 75,000 N is going to be equal to 1,500,000 minus 1,200,000 then plus 75,000. So this one will produce 300,000 plus 75,000. That means 375,000. So this is what we have, right? This is what we have for this 75,000 N. So the next thing is to divide both sides by 75,000. So you have 375,000 divided by 75,000 like this. Okay. The next thing is to divide this, if you do so, you're going to have 5. N is going to be equal to 5, like this. So n is 5. Divide this by this, you're going to get n is equal to 5. Okay, so in the 5th year, in the 5th year, maximum salary is reached. B part of the question says, how much money would a person earn in that time? So that's the total amount he's going to earn. That means how much money in 5 years. So now n is equal to 5, we know it. So I'll now quote the formula. The best one to use is this A plus L, because now I have my L. My L is that. Okay, this is the best one to use. My L is given as what? 1.5. So I can use this. Now we have S5 is equal to 5 divided by 2. Then this is 1.2 plus 1.5. Okay, so we have 1.2 plus 1.5. S5 is equal to 2.5 times 2.7. If you add this and this, you get 2.7. Okay, so you're going to have 2.7 times this, 6.75 million, or 6,750,000. So that's it, the final answer. So this is how much he's going to earn. This is how much he's going to earn in that time. Okay, this is how much he's going to earn in that time. So the next idea, the next question, number 2, said, question 2, find the sum of all the multiples of 3 between 5 and 200. So between 5 and 200, solution, multiples of 3 are all the numbers that 3 can divide. All the numbers that 3 can divide, they are the multiples of 3. So between 5 and find the multiples of all the numbers between 5 and 3. Find the sum of all the multiples of 3 between 5 and 200. So we're going to have 5 and 200 like this. I'm finding all the multiples of 3 in this interval. So the first multiple of 3 I'm going to encounter here is going to be 6. A is going to be 6. If you look at it, first multiple of 3 is going to be 6. 5 is not. So 6 is a multiple of 3. So the next number is going to be 9. So that suggests that my D is equal to 3. So the last term here is 200, but 3 cannot divide 200. I'll go a bit one step backward to see if 3 can divide 199. No, 3 cannot divide it, so 3 can divide 198. So my last term is 198. See? So now I don't know how many terms are here. I'm going to find out by setting up Tn is equal to A plus n minus 1 D. If you do so, that means you can put your L is equal to this as Tn. So 198 is equal to the first term is 6 plus n minus 1. Then D, the common difference is 3. See that? Okay, that means we have 198 is equal to 6 plus 3n minus 3. And so 3n now is equal to 198 minus 6 plus 3. 3n is equal to 198 minus 6 is 192 plus 3 is 195. So n is equal to 195 divided by 3, which is equal to 3 in this one is 6, 3 in 25 is 5. So n is equals to 65. See that? N is equal to 65. So I have 65 terms. 65 terms. I'm going to look for the sum of 65 terms across this sequence. So that means that I'm going to take this formula. I have my first term and my last term. So I'll use this one. Sn is equal to n over 2 a plus l. I'll just use this one, no problem. Let me use this. So the first term, I have my, so that means I'm finding, what am I finding? I'm finding S65, sum of all the 65 terms. So 65 divided by 2. The first term is 6 plus the last term is 198. Like this. So we're going to have 65 times 204. So 65 times 204 is the answer. 204, 65. You multiply this by this to get 20. 2. This is going to be 10. This is going to be 4 carry 2. This is going to be 2. This is going to be 12. So you have 0, 6, 2, 3, 1. So everything is 1, 3, 2, 6, 0. So I have the sum of all the multiples of 3 between 5 and 200 is this.